zero knowledge proofs in the world. Thank you very much, Theo, and looking forward.
Thank you. All right. Hello, everybody. So I'm Theo Mazzu, CTO and co-founder of Wagmi Studio. So we're a Web3 development agency based in France. We mostly work with French corporations, mostly on NFT projects. For example, some of our clients would be La Poste, the French post office. We launched like a NFT stamps project for them. And PMU, which is like a horse racing betting company. And so our business is mostly NFT, but since last year, I've been really looking into zero knowledge proofs on a personal basis, and I really I'm kind of trying to push the company into trying to find use cases for it, because we're more into building like real world applications. And in ZK, for now, there's a lot of infrastructure tooling that's been built, but we're still lacking like a little bit of application. So we're trying to find like what we can build with this, because we see the potential, we see it's powerful, but how we move forward. So essentially, this is what I'm going to talk about today. One thing I need to specify. So let me get a show of hands. Who in the crowd knows about ZK Sync, Polygon ZK VM, Scroll, and all the validity rollup like this? Okay, that's a great deal of people. So it's called validity rollup or sometimes ZK rollup. ZK rollup is a bit of like a misnomer, but I'll get to this later. So this is about scalability. Today, I'm going to not talk about this. I'm going to focus on the privacy aspect of ZK. So this is what I'm going to focus on. So who in the crowd knows roughly what a zero knowledge proof is? So I know. All right. Well, I'm still going to present it. It's going to be useful for half the crowd, and the rest make sure that you understand everything. So a zero knowledge proof, you essentially allow you to prove that a statement is true without revealing any information about that statement. Now, what does this mean? I can give you a better intuitive example for this. Do you know where's Wall-E? It's like I don't know if it's really children's book, but like it's like a book where you have to find like some guy with a beanie and like a striped shirt with like red and white in a huge crowd. So it's pretty hard to find him. Now, so let's say you are in the room with another person. So you have the book in front of you. You want to find him, but you can't. So it's very frustrating, isn't it? So the other person says to you that he knows where he is, but he doesn't want to tell you the location. He doesn't want to spoil the fun, does he? So what he's going to do is that he's going to ask you to turn around, take a big piece of paper, like larger than the book, randomly move around so that the position of the book under the piece of paper is not known, as that cannot be known when you turn around. It's going to make a small cutout right where Wall-E is. And just like a small, so you can see Wall-E, but you can't see the surroundings, so you don't have any context. So when you turn around, you see Wall-E, so you know he has to know where he is. But you don't have any context, you don't know where he actually is, but you have the proof that he knows where it is. So he proved to you that he knows where he is without showing you the actual location. So that's what I was talking about regarding the definition I gave before. So if you want an illustration of this, here's like one example of like Wall-E. So I give you 2 seconds to find him. 1, 2, did you want? Oh, you found him. Oh, really good. That's kind of spoil the fun. But anyway, let's move around. Yeah, so the point is that let's imagine nobody saw him. So I'm going to move here. And I made a little circle around where he is, so like a small cutout. Now, you would think it's probably in the center, but you see that it wasn't, right? So if I go back, it was actually here. So, but what happened is that I took that piece of paper and I moved the book somewhere. So it's not, it looks like in the center, but it's not. So now you can see where he is, obviously. But essentially, the proof was just showing this. Does this give you a better understanding for those that understand zero-knowledge proof? That's a very common example. I found it pretty intuitive. Now, a little bit less intuitive example, but for the people that are more tech, that will give you an example of practically what zero-knowledge proof is. If you want an example of a simple ZKP, that would be a Schnorr signature. So essentially, take it as like private input is your private key. The public input is the message. you have an output. With that output, anyone can verify that the public key associated to private key was used to sign that message, and therefore you know that private key. Now, you may wonder why I didn't say ECDSA or DSA, which are more common. Those are actually not zero knowledge. I don't know exactly why, but they are proof of knowledge, but they don't satisfy all the requirements of zero knowledge. There's no signature does. So what we can do with this? Bring privacy to the masses. So essentially, we have it's a very different paradigm from before in cryptography. It's not encryption, decryption. You're just trying to prove something. So that data is not encrypted. Those private inputs are not encrypted. They're just not known. They don't leave the device of the user under any form. That's it. Now, some example. Prove that you are over 18 years old without actually revealing your age. It could be interesting if you're not really into giving your age. Prove that you have the financial means to pay the rent without revealing all those documents that they sometimes ask for, which is kind of a bit annoying sometimes, salary slips, work contract, bank statements, or similarly convince someone else you are reliable enough to repay the loan you're asking them. So kind of like a reputation, proof of reputation, if you will. Or prove you are a citizen of a given country without revealing all the information of your national ID or your passport. So that's a pretty great example of what you could do. But the question now is that if you want to sell it to the public, if you want people to build real-world applications with this, you need to ask this question, since we're talking about the privacy aspect. How much people truly care about privacy, about their privacy? I'm going to ask the public. That was what. Yeah, so what do you think about this? I'm going to go by a show of hand. Who thinks that they care? Yeah, they seem so. So it's like a paradox. So they say they care, but do they act like it? No. So, who is in the crowd cares about their own privacy here? All right. Well, that's not too bad. Who uses tools or services like Instagram, WhatsApp, Telegram, TikTok? Yeah. So, yeah, well, those are Telegram is probably a little bit better, but still not as good. You would have Signal, which is better. But you can activate actually, did you know that you can activate end-to-end encryption in Telegram? Do you actually use it? Okay, so the feature is here, but you don't use it. It's you have to activate it. It's not by default on Signal, but yeah, it's kind of hidden. So yeah, maybe not so much after all. In a product, what people want is convenience and simplicity. So they want something that they can use without thinking too much, without too much effort. I mean, at first, if you have a complex product that gives you more privacy, they may want to try it, but it's going to get exhausting over the long term. So they will just look for another solution. They will get exhausted. So for example, compare two similar applications. So exactly kind of the same purpose. One is privacy preserving, the other is not. Is privacy preserving enough of a competitive advantage over the other? Especially over the long term. So for example, why Signal has overtaken WhatsApp or Telegram? Signal is over, I think, under 100 million users, while WhatsApp and Telegram are over around 1 billion. So there's a huge difference. But maybe it might be that WhatsApp and Telegram are more complete in terms of features, but still, I think there's an example here. And I was working with somebody at a hackathon, ZK Hack, on could call a privacy preserving dating app. So if you'd add this versus Tinder, honestly, would people actually use it over Tinder if it's exactly the same thing? Would they? Probably not. It's not enough. You need new features. You need something else on top of it. You did have some revelations from the likes of Snowden, WikiLeaks, the Cambridge Analytica scandal that shocked people. They made them more aware about the way the data are handled. But in the end, they mostly forgot about it, I would say. And they just used whatever tool was more convenient to them. Another thing, those are more technicals. Apps relying on ZKP maybe a bit slower, less performant in the foreseeable future, but this will be reduced in time as improvements are made, optimization and hardware acceleration. And from the developer's perspective, you need to think about how you integrate ZKP into your app because it's a quite different paradigm from what you're used to. So if you take the developer, it's not as derogatory, but as kind of lazy sometimes, you might not want to make the effort to integrate this, especially if you want to ship fast. But there may be a way. Businesses care about privacy because it can cost them not to. Now, the reason why is that regulators did not forget about those privacy leaks, and they put in place measures to protect the privacy of their citizens online, especially in the EU with the GDPR. So now it creates an incentive for businesses to protect the privacy of their users because otherwise they can face huge fines. We're talking huge fine for big corporations that have huge incomes. If I remember correctly, but someone can correct me if they know, I think it's up to 10% of the income of the company that can be fined. Is that right? Yeah. Bigger? 15? So if you see, when you have this, definitely you need to care about it because you don't want your business to go bankrupt if you get 100% of your income tax. So that's a big incentive, and for that you need to spend more money on sufficiently secure infrastructure so those kind of data breach don't happen. And in this case, zero knowledge proof, and also in combination with FHE and MPC, can potentially alleviate some of this risk and cost. Now, for a little bit of more context, FHE stands for full homomorphic encryption. This is more like an encryption mechanism, but essentially it allows you to do treatment over encrypted data. So this is another, coupled with ZK, you can do a lot of stuff with this. MPC is you can see it as ZK, but for multiple parties, essentially, just more than two. But again, it's not that simple. There's regulators in the way. You need to convince them to use this. They may not see it as efficient to just have a proof. Now, why is that so? There we go. So, aren't ZK undeniable proofs? You could say they are to a certain level of soundness, 99.9%. But it really depends what you're trying to prove, the proving schemes, the proving system you use, and essentially what you coded, the circuit you coded, because you could just come up with whatever you want. And the proving system is still pretty recent. So they need to stand the test of time. And when you do implementation, especially when you do optimization, both can sneak in. And in this case, you can make fake proof, for example, if there's bugs in the protocol. So what we need to do is come up within the industry with standards within ZK, trying to agree on what proving schemes we find reliable, try to agree how we can make a proof for a given thing, and then come with this to the regulators because they need something concrete. Because essentially when you go and present them with your database with a bunch of proof, they're going to be what's that string of random characters? It doesn't look like, for example, let's say you have you're doing a ZK KYC. So you're making a proof with the digitalized version of a passport that you are, for example, a citizen of France, that you are over 18. So you have this strings of characters stored in your database, which is the proof, and they see this and they say, where's the passport? So you need to convince them that this is sufficient. So that's going to require a lot of convincing. And there's one more problem. So data is a very lucrative business. You can, with all those public data, you can know a lot about your users, sell them more stuff. So how can they earn money if all this become private? How do they use it? Well, it can be a problem. You could ask maybe users to pay, but would users really pay for what they currently don't pay for? Now, would you pay for Facebook? Would you pay for Messenger? Would you pay for those kind of stuff? Probably not. But maybe you can still leverage it because you can actually use ZK and also FHE with machine learning models. So you could still use ML models with private data. So most of those public data are used through machine learning models to make prediction over them in order to learn to like give the user a more relevant content, for example. So you could use those two alternatives. Now, just to compare roughly, ZK ML has the disadvantage to have to be run on the client side, at least if you want to keep full privacy of the inputs. Otherwise, you would have to send the private inputs over the internet, which kind of breaks the paradigm. FHE can be used on the server side, which means you can have like more computing power, but you do have a stronger security assumption because it's an encryption mechanism and one day it could be broken. The main advantage of ZK is that private input, not encrypted, not sent anywhere. So essentially, it will never be revealed, even if you find a way to make fake proof, essentially. But this may only satisfy some of the use cases companies have. And so it still remains an open question. Like building a business model around private data is going to be a huge conundrum that we have to solve. And bonus question. Don't have the answer to this. It's kind of an open question. What about intelligence services? What do they think about this much secrecy? Would they like it? But anyway, let's keep on building because like this is not going to be solved by itself. Nothing is ever easy, but this was important to bring out like what we need to solve essentially in this industry. So that's why I made this presentation and because of the challenge I faced when I tried to find use cases for ZK. Privacy-wise. And if you want to learn more about zero-knowledge proofs, you can scan this QR code generated by distributors, generated using AI. And this will lead you to the ZK Hack website. So this is one of the best places to learn about ZK, and also a pre-active community on Discord. They organized the ZK Summit, which I went to in London last week. There was one in Lisbon in April, and also the ZK Hack. So that's the hackathons focused on ZK. I went to in Lisbon in April as well, and they will organize the next one in Istanbul, November 10. So mark the dates if you want to go. You will find the application form on it as well. And this is, if you want to stay in touch with me, you have all the information to contact me. All right.
I think we have time for some questions, yeah?
What's your favorite use case that you have found for now for DK?
So, I'm gonna list a couple. So like so far I would say ZK KYC. I like it because like recently, a few months ago, I heard of like a company that was doing KYC. So essentially like regular KYC, you send your passport, they scan it, and they store on the database, and it was actually hacked. So yeah, that was a bit annoying for the people that got their passport on that. So that solves the problem pretty neatly. You just need to have like a ML model you can run with the ZK, analyze the passport, and keep the proof of that, or wait on the state to generate some kind of digitalized version of identity. That may take some time to generate proof out of that. Another thing I found interesting is like ZK proof of reputation with proof of humanity. Proof of humanity is really important. If you want, like in blockchain, will be very important. That way you can prove that for example, you could have an app, you have like one account per person. Like right now, you can just create a bunch of addresses and there's no way to tell like if it's the same person. Or you can do some statistic analysis, but that's not going to lead you much anywhere to prevent spamming. So proof of humanity is important. Now, the current clearest implementation of it is a bit controversial. That's WorldCoin. It's kind of intrusive. So they scan for those who don't know, it's like they have this big orb and they scan your iris, and then you can have like some kind of like ID in the app so that you can use to prove that you are a human because you scan your iris essentially. But what happens in the orb stays in the orbs. That's essentially it. But you have other way to build proof of humanity.
Thank you for the presentation. I have one question about the origin. Do ZK proofs and ZK rollups, do they have any connection with Zcash and Zuko?
So, you like Zcash. That's the one that came up with Graph 16. So like they use Zk Snox to make that, to use privacy. So they do use the zero knowledge expect, but in the case of the ZK rollups or validity rollups, which is the best term in this, they only use ZK for the succinct aspect. So SNARK stands for succinct non-interactive argument of knowledge. So they really care about this succinctness. And they don't really use the zero knowledge aspect. So essentially everything remains public. So ZK rollup is a bit of misnomer. That's why validity rollup is better. Or you could just call like a rollup like Aztec, if you know about it. That's essentially fully privacy preserving. They're currently building. It's actually pretty good stuff. You could call that either like a true ZK rollup or ZK rollup. That's kind of a meme right now in the industry. But yeah, but that they use the similar kind of proof, but just don't use the zero knowledge aspect in the case of the ZK rollup, like Polygon, ZK VM, or Scroll, or others. ZK is actually, it's a pretty old stuff. Like the first paper on it was in the 1980s by Mikhaili and Golvasa. You may know Mikhaili as the founder of Algorand. He comes up in a lot of papers. It took some time to be usable, like probably like over 10 years ago it started to be usable. It was really theoretical, but it's an old stuff. It's like way before Zcash.
As you were at ZK Hack, like what type of things were people hacking today? Because the proving of passports and KYC, that has been around, this idea, for a while. I'm just curious, what's at the cutting edge that you're seeing right now that people are building?
So what people are building during the ZK hack, the last ZK hack, there were a lot of like tools that are infrastructure, like optimization of some like stuff, tooling, or some like tools for other developers. End user application, not so much. So like for example, some people were like you had Polygon Maiden that was like offering some bounties to like implement some like primitives. Like people were working on this. So the first ZK hack was like mostly those kind of projects, not any end users. But like I'd say like you go like, wait a couple more months till we can build something like in production. But for now I'm actually pretty interesting to see what's going to happen in ZK hack in Istanbul.
Yeah, thank you for your speech. The question about regulators, you told that we need to suggest something to regulators, but I think you heard about the paper from Vitalik and from Amin. So can you just comment it? What do you think about this solution? How it will works for regulators? Yeah, so this is the question.
Well, actually, can you just like the paper from Vitalik? Can you give me a reminder about this?
Yeah, it's just a paper where they introduce some entity like ASP, and this specific group can choose which deposit they can use during the withdrawal process. So they can just define some specific rules and understand what deposits was clear and what is not, like what is dirty money and what is not dirty money. So in this case.
So in this case, it's like kind of like a jury, like that would be. So I don't know how that works with regulators, but like, so you would judge if something is clean, something is not.
Yeah, we can talk about.
No, I didn't read it. Yeah.
Thank you very much, Dale.